Hello students, welcome back. Previously we went through some examples of radical equations. We went through these three examples. First two were pretty benign because we have just constants outside the radical. X is only inside. So, sorry about the typo, cube of both sides to kill off. That computation is easy. Again, no x outside, so isolate the radical and square both sides, and that computation is easy. You may have to do some work checking the possible invalid solution. This one, on the other hand, was major pain in the rear end. Why? Because we have x expression outside the radical as well. So isolate the radical, and when you take square of both sides, I have to take the square of this one. So we get the complete square, and then we end up with far more complicated equation. Two candidates, turns out only one of them is the solution, and you can check that to original equation. And final checking process, what can I say, is a calculator work. Make sure you punch correctly. Now let's consider even harder problems. What if we have two radicals, three radicals, four radicals? As a matter of fact, if you can do two radical problems, then I can assume you can do 15 radical problems too. It's just that it takes more time. Basically, you are reducing two radical problems into one radical problem and then doing that. So if you have three radical problem, reduce it to two radical problem, and then reduce again to one radical problem. Basically what we are working on here is reduction. There's no magic solution. You have to reduce. How do I reduce? So for one radical, square both sides, and then when you square both sides, the second radical does not go away. You just have another radical equation. So here we go again. Solve for the second radical and then square both sides. That's the way the reduction works. I'll show you. Here is the problem, and this one, I'll just go ahead with the solution here. Isolate the first radical, flip the second radical to the other side, so isolate the first radical, and square both sides. Do you see that? So the second radical, which I'm highlighting in green, flipped over here, and first radical brown, that's isolated, stays same. And if I square both sides, this green, this brown radical squared, so you just have just 2x plus 3, radical will disappear, but this green will not go away. That's a problem. Here, 2x plus 3, left hand side, in the right hand side, if you FOIL out this, you're gonna get something really messy. Two times 2 is 4. 2 times the square root, you see, you have the square root. Another 2 times the square root, you see, that's square root. And square root times square root, okay, that'll go away. Or I can use complete square formula like this. 4 plus 2 times a times b, so 4 square root of x plus 2, and plus this one squared, which is x plus 2. So what do we have? We have a one radical equation. Two radical equation was reduced to one radical equation, and you can go from here. hard part begins now, I said. And then yeah, we got up to here. And then let's simplify. X 4 plus 2, so x plus 6, and then 4 square root. And then flip everything to the left except for the radical, because I have to isolate this radical. So subtract x away, so x subtract the 6 away, so negative 3. So we get x minus 3 is just 4 times this radical. And then square both sides. Complete square again, and then 4 times square root squared. Finally, both square roots disappear. We have 4 squared, 16, and square root squared, so just x plus 2. And to the left hand side, we get complete square. X squared minus 6x plus 9. So we have a quadratic equation to solve. Simplify, and it turns out we have this simplification. So this factorization yields x is 23 or x is negative 1. But it's still not over. You have to plug in x is 23 into this, and x equal to negative 1 into this, and then run your calculator to see if you get equality. If you do that, it turns out x equal to negative 1 is not a solution. X equal to 23, yes it is. And indeed, you get 23 as the solution if you run computer algebra system. So here's the full solution. Isolate one radical with respect to the other, and then square both sides. That'll reduce 2 radical problem into 1 radical problem. Now solving that 1 radical problem, well, we went through 1 radical problem before, and it's long, and basically that's what we have to do. That's a hard part. And then in the end, your calculator work. Ready for this? We have 2 problems here. Let's work out the first problem. Stop the playback and work it through. And if you want to challenge more, here's another one. Again, stop the playback and then work it through. Tell me what you get. Ready? Did you get the answer, or did you end up giving up? Okay, let's begin. Putting some space in between. All right. Flip the 1 radical to the other side. This is negative, so flip it over, then I'm going to get positive. So I don't have this anymore. Something is not right. Okay, alright, flipped it over successfully. And then I'm going to take square of both sides. If this had been cubing root, I have to take cube of both sides, and that's going to be, major pain in the rear end. Taking square of both sides is hard enough. So let's go ahead. Left hand side is pretty much all set. 3y minus 5. And the right hand side, let's use complete square formula. A squared, so 4. 2 times a times b, 2ab, so 2 times 2, 4. 4 square root of y plus 7. And then b squared, which is y plus 7. Square root disappears. Let's simplify further. 3y minus 5 is, let's see, y plus 7, y plus 11 plus 4 square root of y plus 7. Did I do this right? 4 plus 7 is 11. We got that. Okay, let's flip these to the other side. 3y minus y, so we have 2y, and then -5, another 11, -16, and that's 4 square root of y plus 7. Okay, alright, isolated. I can square both sides, but not so fast. Let's simplify first, so that the computation becomes less painful. Y minus 8 is equal to 2 square root of y plus 7, because everything is even number here in the left hand side. Now I'm ready to take square of both sides. So we have y minus 8 squared, and then this thing squared. So to the left we have complete square. Y squared minus 16y plus 8 squared is 64. To the right, 4, and then y plus 7. If you don't like to use complete square formula, you can FOIL y minus 8 times y minus 8. Y squared minus 16y plus 64, and here 4y plus 28. Almost there. Y squared minus 16, and then another 4, so negative 20y. 64 minus 28, 56. Can you factor this? It's not too bad, it's monic. And if everything fails, then you can always use the quadratic formula. 56, 6 times 9. No, that doesn't work. 18 times 3. 14 times 4. Factors of 56 adding up to negative 20. Oh, it cannot be factored? That's quite annoying. It's quite likely that I made some computation mistake somewhere. It shouldn't be this hard. It says 18. What mistake did I make? 64 minus 28 is 36, not 56. That's why. Okay, alright. So now this looks like much easier to factor. So 36 18 times 2, y minus 18 y minus 2 equal to 0. So I'm getting y is 18 or y is 2. And checking which one is correct is left to you. Maybe both correct, maybe both wrong. And Mathematica says only 18 is the correct answer. So only this is correct and this is gonna be wrong. But of course, checking that is left to you. What do you think? 2 radical problems. Yeah, pushing the envelope.